as of you know, designing buildings suitable to the context and providing thermal comfort for the occupants is the need of the hour because of global warming, because of high concentration of pollutants in the air. As all of you know, it is a rising threat for the people to stay inside the house, no, because of high temperature and other pollutants. So, how best architect can give his service to provide a suitable buildings to the context. First, the analysis of context is more important in terms of sun path, in terms of wind direction, so that you can utilize maximum the natural forces to give a comfortable thermal conditions inside the building. So, you need to analyze the angle where you want to place and how to design building, what kind of materials to be used based on the context. Overall, you can say it as a context design. So, first you should try to understand where to locate, how to orient, at what angle you can get sun rays, at what angle you can get the breeze in summer, winter. So, throughout the year the occupant should be comfortable. That is the duty of an architect to see into. So, with these instruments you can analyze how to replace or how to tilt and what is the optimum angle in for our context, for our latitude and longitude, that you have to study, then you have to start a design. So, that can give a better thermal comfort to the occupants. So, I hand over to Purni to continue the demonstration.
So, students, as ma'am had explained the brief about the the global warming and then the energy crisis that we are facing in this current period of time. So, each one of us as an architect, we are more responsible in designing the buildings, and that is why we have been introducing a climate responsive design in your AD studios. So, we are incorporating the climate responsive designs. So, these instruments help us to identify uh, these instruments help us to identify the passive design strategies. Okay. So, we have already worked out few exercises. So, these are the practical sessions which we are doing it. So, for example, this instrument, you know, this is a solar chart. So, you have learnt about your solar angles, the solar azimuth angle and the altitude angle. So, those two angles are very important for us to design the shading devices, correct. So, we are using many formulas to find out the length and the depth of the shading devices and whether you need horizontal shading device, vertical shading device or a egg-rate shading device. So, to find out that, you have to know for a particular geographical location your the sun's altitude angles, the solar altitude angle and the azimuth angle. So, this instruments helps us to find out your both angles. So, we have fixed north pointing towards the north to the current geographic location. Our base is flat here. So, this outer circle whatever you see, you can see north starts from 0, ends at 360 degree. You can, it is one circle from 0 to 360. And then you have this scale which can move around to point towards the azimuth angle directions. And this scale whatever you see, I think all of you can see the scale that is written there. This is your altitude angle. So, this instruments what happened, I mean now today is what? Today is 14th of June, time is around 3:20. The sun position is the sun position keeps changing from morning to, by the time the sun sets. So, based on the position, we can actually adjust this, okay, this is a movable thing, and we have to align it such a way that the 3 pin points, the shadow does not fall down. Then you lock the position. Then for this particular time, that is June 14th by 3:20 p.m., your solar altitude angle and the azimuth angle you can find. For that you can move and then find it, okay. That is one. Then for example, I want to find out for a different day in a year. For example, I want to find the azimuth and the altitude angle. I want to find out the azimuth and the altitude angle for a month of say August or July. So, we have a sundial with us. So, you can fix the sundial to this instrument, okay. And where is this? Can you attach the fuel base for this? So now this instrument is allowing us to rotate, okay, rotate the base, okay. So when you have to find out for a different day or a month in a year, so that no, our building will be exposed to the external environment throughout a year. So we have different seasons, like we have a winter season, summer season, and the sun position varies, like it is much at a lower angle during the winters and it is much at a higher angle during the summers. So for whichever the month, you can see the month's reading written on the side of, this is a sundial, okay, it is written here. So the November, December, October, September, it's written. So you can move the base, okay, so that you don't find the shadow falls on that particular, this is the time whatever you see here, okay, the circular time is the time from 6 am to 6 pm, from the sun rays to sunset. So you can exactly point the shadow on for which month and which day, time of the month, okay, you want to know the sun position. So you will be getting the altitude and the azimuth angles for it, okay. So now, yeah, we will remove this. Please bring the model, the house model. Yeah, you can remove the piece. Yes. Yeah, you can. Yeah, or you keep it. Yeah, you keep it there. No? Yes. Yeah. Yeah. Place it. Place it. So this is a what to say? This is a base model of a room design. Okay. For example, now this is a room you have designed. So when we have to reduce the energy usage inside our building, so main thing what we will have to do is the passive design strategies which we will have to adopt. The passive design strategies are nothing but you are designing a building which is responding to the climate. So you are reducing your energy usage within the building. Okay. So the moment, the first thing starts with the orientation of the building. Okay, because you know when your the sun is very harsh when it is in the direction of east and west. So you align the building such a way that your longer axis is aligned towards north-south, okay, so that the less amount of heat energy is transferred inside the building. So once the moment you reduce the amount of heat energy which is transferred inside the building, automatically my energy usage for the other mechanical, what to say, the equipments which I use to make my space comfortable gets reduced. So whatever I reduce the usage, okay, indirectly it helps me in reducing the carbon emission into the atmosphere, the carbon emission whatever is being emitted out in production of that energy, understand. So now here this helps us in orienting our building best. Okay, now for this date we are doing the experiment here. So there are certain shading devices, I think you can try it yourself, okay. So you can pick the shading devices. What you do is, this is a model which is giving you a height of 10 feet, okay, and a 10 by 10 room, a square room is created, and this is the size of the opening. So now there are various sizes of shading devices. No, give me the smaller one. Yeah, that one. So now see, my building is oriented towards west. So this is where I have the sunlight coming in. So you can see, all of you just come and see, the sunlight penetrates till end of the building. This is actual model. So when you build a room of this size, when your wall is exposed towards the west, you can see the harsh sunlight, I mean the amount of heat energy also which is getting transmitted inside the building. So when I want to stop it, what I do is, I will add some horizontal shading device. Now come and see. Now see, without the shading device, all of you can just come and have a look, okay. Just see where the, till where the sunlight is reaching inside. Come over, come this side. Okay, now I add this. Now again see, now have a look at this. So the penetration of the sun, okay, it is reduced because the shading device, the shading device is stopping the heat energy that is transferred inside the building. See, for example, again based on the heat energy that will be transferred, and for a colder climate maybe you need the heat to get inside the building. So accordingly you will have to design. When you want more heat energy to be transferred inside the building, you can reduce your shading devices. When you want to avoid the heat energy to enter inside your building, the less amount of heat to be transferred inside the building, then what you do, increase the shading devices. And we have the vertical shading devices as well. Yes, so you can actually experiment with these. I mean, now for example, when I want more protection for my windows, when I have a larger window, for example, see, these are larger windows. Let me remove this. These are larger openings. So when I have a larger opening, get me that longer one. Yes. not fitting. Yeah. Okay, so the moment I cover this, I still, you can see, have a look at it. There is still a lot of okay, heat which is getting inside my room. So what I do, because the west wall again, it will start re-emitting this heat during the night time, when, I mean, mostly when we have bedrooms on the western wall, western side. Okay, so then what I can do is, I can additionally add some horizontal shading devices to reduce the amount of heat energy that is getting inside my building. When, if this is not done, okay, so what will be the impact on our building? Heat up. So you will end up using your mechanical devices to cool your space, so which is adding more of energy. See, even see, for example, I mean, we cannot avoid using our mechanical devices. Here our attempt is to reduce the hours that we are using our mechanical devices. Understand? So from this experiment, you can actually measure the length of your shading devices. One is you are using the, you are finding out the solar azimuth altitude angle, and then you decide upon your length and the height of your shading device. This is a practical example which gives you, you can exactly measure, because this is all scaled model. You can actually measure. For example, now this is 600 mm. 1 square will be 300. Okay, so 600 mm will be the depth of my what to say, the shading device. Clear to all of you? Okay. Okay. So now we have understood how we calculate the shading devices. Okay, the length and the height of the shading devices, and whether the horizontal and the vertical devices are additionally needed. Okay, to safeguard my room from the excess amount of heat to enter inside. So now here, this is another model which helps us to identify the heat transfer through the roof. You know, the roofs are always exposed to the sun. Okay, the walls again, when the sun moves to the west, your east wall is not exposed to the sun, but then the roof is one part of the building which is almost exposed to the sun throughout the day. So here we have different roof forms. This is a small experiment for us to identify which roof form is actually letting a very less amount of heat transfer inside the building. Okay, so you have a vault roof, you have a folded plate, you have a pitched roof, and this is a pyramidal roof, and you have your dome. Okay, now please record the readings inside now. So let me take this. Okay, you take the reading of that roof, and let me take the reading of this room. Okay, we are just kept here, it is showing 10. Yeah, 10. Okay, now let's insert it back. Okay, and when this roofs, I mean, it is all painted black in color to actually absorb more heat. Okay, so that quickly you can record the readings. So when this is, the sun is so when it is exposed to the sun, so after 10 minutes, okay, after 10 minutes, if you again take the reading, you will know which roof form is actually transmitting more amount of heat inside the building. Okay, I think, yeah, the sun is back. So after 5 minutes you can test. So these are the passive design strategies which we will be using it in the design. Okay, so that we are moving, because we are moving towards the energy efficient buildings, and even in the what to say, the Conference of Parties 26 meet, okay, the COP 26 they call it as. So India has made a commitment, okay, about the energy, the climate action, what India will take. So we have Panch Amrit, okay, which has been listed out, okay, by our Prime Minister. So we'll have to achieve the targets. So by 2070, we will be going net zero. Okay, by 2030, 50% of our energy usage has to be generated by renewable sources. Okay, so when we have certain targets, as architects, we'll have to apply these kind of design strategies inside the building to reach that target. Okay, so let us get exposed to the sun for 5 minutes, then we can check the temperature. Yeah, you have any doubts, you can ask me. So you know, like, first is orientation of the building, then again the size of the openings also we see. Okay, so whether based on which climate, whether you want larger openings or you want smaller openings, and what kind of shading devices you go, and what kind of roof forms we will go into, okay, to design a passive design strategies based on the climatic